The Cold War was an era defined by secrets, invisible borders, and an unrelenting race for technological dominance. In the late 1950s, the United States faced a critical intelligence crisis. The skies over the Soviet Union were no longer safe. The shootdown of Francis Gary Powers in his high-altitude U-2 spy plane in 1960 proved that the Soviets had developed surface-to-air missiles capable of reaching the upper limits of the atmosphere. The Central Intelligence Agency needed a completely new weapon, a craft that didn't rely on stealth alone, but on a variable that no missile could match: absolute, uncontested speed. Under the absolute secrecy of Lockheed's Skunk Works division, led by the legendary aerospace engineer Kelly Johnson, a ghost was born. It began as the A-12 under the CIA's Project Oxcart at a hidden base in the Nevada desert, eventually evolving into the legendary SR-71 Blackbird. To understand the sheer madness of the Blackbird, one must understand the environment it was built to dominate. At Mach 3, air resistance turns into a thermal furnace. Standard aircraft aluminum would literally melt at the temperatures generated by atmospheric friction at 3 times the speed of sound. Kelly Johnson knew that the only material capable of surviving this extreme environment was titanium. But in the early 1960s, the United States did not possess the domestic supply of titanium required to mass-produce such an aircraft. The world's largest supplier of high-grade titanium was, in a twist of supreme geopolitical irony, the Soviet Union itself. To build their ultimate weapon against communism, the CIA had to engineer one of the greatest covert logistics operations in military history. Utilizing a complex network of fake front companies, shell corporations, and third-party third-world buyers, the United States secretly purchased thousands of tons of raw titanium from the Soviet Union. The Soviet government literally sold the United States the very metal used to build an aircraft designed to humiliate their military infrastructure for the next 3 decades. Every time a Blackbird blasted over Soviet airspace, it was a supreme manifestation of American espionage, flying on wings made of Russian metal. But transforming that titanium into a functional aircraft required rewriting the entire textbook of aviation physics. On the ground, the SR-71 looked broken. If you walked up to a Blackbird resting in its hangar, or on a wet tarmac before a mission, you would see pools of fuel actively leaking from its fuselage. This wasn't a mechanical failure. It was an intentional, brilliant engineering necessity. At Mach 3, the skin of the aircraft would heat up to over 600 degrees Fahrenheit. This extreme thermal expansion would cause the metal panels of the airframe to expand by several inches in mid-flight. Kelly Johnson designed the fuel tanks without internal liners, allowing the panels to remain loose on the ground. Once the aircraft reached supersonic speeds and high thermal friction, the titanium skin expanded, locking the panels perfectly into place and sealing its own fuel leaks in mid-air. The fuel itself was another masterpiece of industrial chemistry. The Blackbird ran on JP-7, a highly specialized propellant designed to resist ignition under extreme heat. JP-7 was so chemically stable that you could drop a lighted match into a bucket of it, and the match would simply go out. It required a highly volatile chemical catalyst, triethylborane, to ignite the massive Pratt & Whitney J58 engines. These power plants were not traditional turbojets. They were complex, hybrid power systems that functioned as ramjets at high speeds, using movable bypass cones to channel air directly into the afterburners, effectively turning the air resistance of Mach 3 into a massive fountain of forward thrust. Flying this machine was an experience closer to space travel than traditional piloting. At 85,000 feet, the atmosphere is so thin that it can no longer sustain human life. If a pilot's cabin suffered a sudden depressurization at that altitude, the atmospheric pressure would drop below the boiling point of human fluids, causing the pilot's blood to instantly boil inside their veins. To survive this twilight zone between Earth and orbit, the David Clark Company designed specialized, fully pressurized flight suits. These were not standard military flight gear. They were identical, heavy-duty spacesuits worn by NASA's astronauts. The pilots breathed pure oxygen for hours before takeoff to purge nitrogen from their blood, preventing decompression sickness during their steep ascent into the stratosphere. Operationally, the Blackbird was an absolute godsend for Western intelligence. Flying over North Vietnam, North Korea, and the heavily defended perimeter of the Baltic Sea, the SR-71 captured high-resolution imagery and electronic data that satellites of the era simply could not provide. The aircraft had no weapons, no defensive countermeasures, and no electronic jamming gear. Its official defense manual contained a single, chillingly confident instruction for when an enemy missile launch was detected: push the throttle forward, accelerate, and climb. Imagine being a Soviet defense commander in 1966, hidden deep inside a restricted air defense bunker. Suddenly, your radar screens flare with a high-altitude intrusion, moving at a speed that defies the laws of physical motion. You scramble your interceptors, putting your best pilots inside the formidable MiG-25 Foxbat. The Soviet pilots would push their jets to the absolute limit, trying to climb into the thin stratospheric air, their massive engines literally melting under the extreme stress of the pursuit. The Soviet pilot would look up through his canopy to see a terrifying, fluid black silhouette cruising casually far above his maximum ceiling. The pilot would lock his radar, pull the trigger, and launch an SA-2 surface-to-air missile. For the American crew inside the cockpit of the Blackbird, a warning light would illuminate, flashing a steady rhythm indicating a hostile missile track. The pilot wouldn't dive or dodge. He would simply push the mechanical throttles forward. Within seconds, the hybrid engines would roar into life, unleashing a colossal wave of afterburner thrust. The SR-71 would accelerate past Mach 3.2, leaving the multi-million-dollar Soviet missile to detonate harmlessly in the empty, thin air miles behind it. The ghost would vanish over the horizon, leaving nothing behind but a thunderous double sonic boom and the shattered pride of the Soviet military apparatus. Even the highly capable Swedish Air Force, utilizing their advanced JA-37 Viggen interceptors, managed to achieve radar locks on the SR-71 over the Baltic Sea by predicting its precise flight corridors, but they could never realistically threaten it. The Blackbird was simply too high, too fast, and too advanced for anything the world could throw at it. Throughout its entire operational history, spanning nearly 3 decades of high-stakes reconnaissance missions, over 4,000 missiles were fired at the SR-71 by hostile nations. Not a single missile ever managed to shoot it down. Not a single enemy projectile ever managed to scratch its titanium skin. When the SR-71 Blackbird was finally retired in the late 1990s, it did so completely undefeated, remaining the fastest air-breathing manned aircraft in human history. It stands today as a legendary, magnificent monument to an era when American engineers looked at the seemingly impossible laws of physics, smiled, and built a machine to break them anyway. A silent ghost of the stratosphere, untouchable, immortal, and forever ahead of its time. Thank you for watching this chapter of hidden military history on the Dark Vortex. If you believe in the power of legendary engineering and untold historical truths, hit that subscribe button, leave your thoughts in the comments below, and prepare yourself for our next deep dive into the shadows of the past.